So we are finishing our linear programming. This is our second last section. Today we're going to look at how to solve for Q, like how to come up with that Q formula, okay? And how to come up with the constraints. And the constraints are just the inequalities, right? So we've tried some of these before. We've tried to come up with inequalities from word problems. You have never really tried to come up with that objective quantity, that Q formula. But we're going to do both today, okay? And then you'll work on some assignments. We'll see how long it is. I might give you some time tomorrow. And then guess what 6.5 is? We're going to put it all together, okay? So we're going to come up with our constraints, come up with our Q formula. Then we're going to graph it. Then we're going to find the points. And then we're going to take those points and put them into our Q formula and tell us what's the max or min. Okay? So come today, you're learning the very last thing you need to know for this unit. Okay? 6.5 is just shoving it all together. So let's take a look here. 6.4. To solve an optimizational problem, you need to determine a combination of values between two variables. We always have an X and a Y, but in words, okay, sometimes there are ham sandwiches and egg sandwiches, remember? Right? So you have to decide, you're not going to write ham sandwich and egg sandwich all the time. We don't like that. We're going to write it in X's and Y's, okay? When you create a model, the first step is to define the variables, right? Your first step, define your variables. Your second step is to create restrictions, okay? Those are really constraints, okay? So you're going to define your variables, you're going to make constraints with them, and then you're going to come up with a quantity to be optimized. That's your Q formula, okay? And then from that, you graph your constraints, find your points, substitute those points into your Q formula, and decide your maximum or minimum, okay? A key thing to think about is some equations, they don't, like when they give you a word problem like that ham and cheese and the egg sandwich, they never told you, guess what, you can't have negative sandwiches, right? We're going to make -3 egg sandwiches. Doesn't happen, right? Doesn't make sense. Right, you would just have 0. You can't make -3 sandwiches. So in some word problems, they don't tell you that, right? You have to just think about the situation. Oh yeah, we can't make negative sandwiches, so X has to be greater than or equal to 0, or Y has to be greater than or equal to 0. So you have to think of those situations, okay? Some key words to work for: maximize, minimize, largest, smallest, greatest or least. That'll tell you, that's the thing you're optimizing, okay? So when you're looking for maximum, minimize, large, small, those things, those will come up to be your Q is equal to formula, right? Those are going to be your quantities that you're maximizing or minimizing, okay? We usually write the Q formula first, get that information out of the way, and then we come up with our constraints, okay? Constraints, usually they tell you different things, like you can't have more than 50 people in that room, okay? You have to make, what was it, 450 sandwiches or something like that, okay? So they give you numbers to deal with. Those will deal with constraints. Those are, you can make into inequalities. So let's just do some examples, because that's probably going to be the best thing. Look at a couple examples, then I've got some for you to practice. 3 teams are traveling to a basketball tournament in cars and minivans. Each team has no more than 2 coaches and 14 athletes. Each car can take 4 team members, and each minivan can take 6 team members. No more than 4 minivans and 12 cars are available. The school wants to know the combination of cars and minivans that require the minimum and maximum number of vehicles. Create a model to represent this situation. Okay. So, did you see the word maximize and minimize? Right here. So they want to know the combination of cars and minivans, right? Right? So the number of minivans and the number of cars, well, we kind of need to know which one's going to be a minivan and which one's going to be a car. Okay? So my first step is to write down what x is equal to and what y is equal to. Yeah?
When it says it can take that amount of team members, does that include the coach?
Team members are coaches and athletes. That's what we consider a team member. Okay? Good question, and clarifying would be good even on an exam and different things like that. So what do you want your x value to be? Cars, and y being minivans. So, what's our objective quantity going to be? How do you figure out how many cars and minivans the total is? You just add them up, right? There's nothing special. If I'm taking 2 cars and 6 minivans, I'm taking 8 in total. How did I come up with that value? I just added them together. So my objective quantity is just going to be x plus y in this case. Nothing special, right? We just want the number, and x is going to be the number of cars, y is going to be the number of minivans. So, before we move forward into anything else, the first thing I think about when I think about constraints, can I have negative numbers of cars?
No.
Negative numbers of minivans? No. So as soon as I finish my objective quantity, I think, can I have negative numbers? And if I can't, I write x can't be equal to, x has to be greater than or equal to 0, and y has to be greater than or equal to 0.
Do you have to write the x and y have to be the element of your numbers then?
We're not going there. But you could, right? Because they're going to be whole numbers. You can't have half of n, right? So if you end up with an equation or an intersection point with half of n, you're going to have to round that up, right? Or down. But if you're filling up half of n, you're going to need another van to fill up, like, or else you're leaving people behind, right? So each team has no more than 2 coaches and 14 athletes. How many people are we taking?
48.
Okay, 2 plus 14, but we're timesing it by 3 because there are 3 teams traveling, right? So 48 people.
That's the most.
That's the most that we are taking at most.
That's it.
Okay, so we have to plan for at most, right? I would think. Each team has no more than 2 coaches and 14 athletes. So we have 48 people. They have 4 minivans and 12 cars. Okay. So lots of people will just do the math and figure out what the answer should be. But in these cases, we have to come up with the inequalities and come up with the questions. Okay? So I might start with this last point just because it seems very easy. There's 4 minivans and 12 cars. So the cars, can they be greater than 12? They have to be less than or equal to 12 for the cars, right? What you have to be for the minivans? Your minivans have to be less than or equal to 4. Okay, so right now what you have drawn is this kind of rectangle thing. Like if you can picture what you're drawing, you've drawn a rectangle because you have a baseline of x and a top line of x, and a baseline of y, and a top line of y. Right? Sorry, I did that backwards. Y's, x's. Okay? Now, we have to come up with some sort of equation that deals with the number of team members and the minivans. So each car can take 4 people. So I'm going to say 4x, right? Because cars are x, plus 6 times y has to be related to this 48 number. Right? Should it be the number of seats in a vehicle, should it be less than 48 or should they be greater than 48? Greater, because you want to be able to fit everyone in there, right? If you choose less than, not everyone's going to be able to come, right? And that's not what we want. We want to be able to fit at least 48 people in, right? We could go 1 person per vehicle, but that's going to waste gas, right? So we want the number of seats per vehicle to be greater than or equal to 48. We want to be able to fit as many people as we can in those vehicles. Okay? Is there anything else? Okay. We dealt with 48 using this thing. We dealt with 4 team members and 6 team members in that equation as well. We put this in. I don't think there's any more inequalities that we have to come up with. Okay? We're done. Because today the only thing we're doing is deciding what variables we have, writing a Q formula, and coming up with the inequalities. Okay? Okay? That's it. Eventually we're going to have to solve this, right? And you know how to solve it because you graph the inequalities, you find the points, and then you substitute into your Q. Okay? Let's look at example 2. Sherwood, Saskatchewan, a refinery produces oil and gas. At least 2 liters of gasoline is produced for each liter of heating oil. The refinery can produce up to 9 million liters of heating oil and 6 million liters of gasoline each day. Gasoline is projected to sell for $1.10. Heating oil is projected to sell for $1.75. The company needs to determine the daily combination of gas and heating oil to produce maximized revenue. Okay? So I see the word maximize. Okay? And so under the maximize, they want to know the daily combination of gas and heating oil. Right? So that tells you which variables you want to maximize. Right? Yes?
It says at least 2 liters of gasoline is produced for each liter of heating oil. And
Yep.
there's 9 million liters of heating oil made per day and only 6 million of gas.
So that's a constraint, right? So at least
It has
2
to make
liters of
more.
gasoline.
Really, you can only make 6 million liters of heating oil.
Right. So it's going to minimize a lot, right? Because it takes longer for them to process the heating oil, so they're going to have to slow down the mine for the heating oil to be produced,
So
right?
it takes longer. Why are they needing a bigger storage?
Yeah, that's
So probably after looking at this summary and graph, they go, oh, well, we'll have to make a bigger storage for that, right? But it's still, then it'll just build up, and they'll have to stop their mine to get that heating oil produced, right? So, going back, the first thing is, decide what your X and Y is. What's your X and Y, Jesse? Gas and heating oil. Okay. The second step is to come up with your Q equation. Nicole, what are we trying to maximize? Revenue. Okay. So a lot of times they don't write Q, they write R for revenue, just so you know. I just write Q out of similarity, but lots of times they write R for revenue. Okay, so we're trying to maximize our revenue. How do you figure out your revenue then? How would you figure out their revenue, Matt? Well, they tell you what? $1.10 per liter, $1.75 per liter. So how would I write this?
110x plus 1.75
Right, that'll figure out your revenue, right? How many liters of gas times 110 plus how many liters of oil times 175? That's your Q, right? So we actually have used this. So we don't put this in our inequality statements because we use it for our Q, right? So be careful. Don't use what you're using for your objective quantity in your inequalities, okay? So, Reese, what did I tell you next? As soon as you're done your objective quantity, you have to think about what? Your inequalities, your constraints. Okay? Can you make negative numbers of your constraints? You can't make negative liters of gas, negative liters of heating oil. Okay? So then we write x has to be greater than or equal to 0, and y has to be greater than or equal to 0. The second thing I look for is there max amounts that can be produced. So there's minimum, is there max? Okay. 9 million of heating oil, 6 million of gas. So x has to be less than or equal to 6 million?
3, 4, 5.
And then y has to be less than or equal to 9 million? So when you go to graph this, you guys, you're going to have to change your scale if you have to graph this, right? A lot of times you're going to have to change your scales when we're doing word problems because they don't go from 1 to 10. Usually they go from 0 to 1,000. In this case, 0 to like 1 billion almost, right? Any other things? Well, we use this, right? I'll just kind of text her. What's the only thing left? This first point. 2 liters of gasoline is produced for each liter of heating oil. At least 2 liters of gasoline. Okay? So I'm going to put gas and heating oil here. Lots of people will put a 2 in front of the gas like Reese was saying. 2. Okay? So let's just look. If I produce 2 liters of gasoline, I only produce 1 liter. Like if this is my X, this is my Y. 1 liter. How do you make it equal? What do you have to do? What do you have to multiply by, I guess? You multiply this side by 2, right? 2 times 1 liter will make it equal, right? So you actually do the opposite of what you think you're going to do because it says 2 liters of this is produced, 1 liter of this. You have to make it equal, right? So if you put a big 2 in front of the X, you're not making it equal, right? You'd get 4 is equal to 1, and that doesn't work. And this is where the mistake is made, right? Just give me a second, okay? So the mistake is made. So I always kind of do a little reference over here. I write down the statement and try and make it equal with the actual numbers, because sometimes variables are hard for me, okay? So I look at the actual numbers and try to make them equal. So that means I need a big 2 here. And then I think about this case. It says at least 2 liters are made. Okay? So they can be equal, but which side can be more? At least 2 liters are made. So this side can be bigger because at least 2 liters are made for every 1 liter of that. So if I made 2.5 liters, and I only made 1 liter of that, I'd get 2.5 to 2 in that equation, right? And so the greater than sign has to go there. You want to press the question, Christina?
If you're graphing this line and unknown, can you just put 1 to 10 and then the graphic thing?
Yes. On your axis scale, you could put 1 to 10 and then put millions in brackets on that scale. So you didn't have to write all those zeros for sure. Okay? Last question.
Okay.
Okay?
If I use that thing with the brackets, then X such that 0 and X blah blah,
I give you a okay. So our last example, a toy company manufactures 2 types of toy vehicles, racing cars, sport utility vehicles, and because the supply of material is limited, no more than 40 race cars and 60 sport utility vehicles can be made each day. However, the company can make 70 or more vehicles in total each day. It costs $8 to make a racing car, $12 to make a sports utility vehicle. The company wants to know the combinations that will result in minimum and maximum costs and what cost those will be. So where do we see the word maximize or minimize? Morgan, where do we see maximize, minimize? Explain what else?
cost.
They want to know about the cost. Minimum and maximum cost. And they want to know possible combinations of racing cars and sport utilities, right? So, Luke, what's our X and Y then? Can I just write SUVs? Are you okay with that? So we now know what we're going to deal with. They want to know the minimum and maximum cost. Okay? So thinking about that, Dylan Gray here, what's our objective quantity? What's the cost? Where did it talk about cost?
$12 to me, and then $8 to increase.
Okay. So you can write Q is equal to, I'm going to write C because it asks for cost, right? It means the same thing, right? It's your objective quantity Q. I'm going to write C for cost. C is equal to $12 for SUVs, so 12x plus $8 for racing cars, so what? That means I use this point, so I don't need to use it. I don't need to use it for my constraints, okay? Then we jump into our inequalities. What do we have to think about, Fallon? Can we go negative, right? Can't go negative, so we need to write our constraints. Our constraints. First off, x has to be greater than or equal to 0. Y has to be greater than or equal to 0. Did they have any maximize? No more than 40 racing cars, no more than 60 sport utilities. So sport utilities are from x. And has to be less than or equal to 60. Racing cars have to be less than or equal to 40. And then finally, is there any dots that we missed yet? That second dot. However, the company can make 70 or more. See those keywords? Or more. So that means when we add the X and the Y together, the number of vehicles, they have to be less than 70 or greater than 70? They have to be greater than 70, right? Or equal to. So what would I write as my last inequality or my last constraint, Dylan? Sebastian. The number of sport utility vehicles and racing cars have to be greater than or equal to 70. Okay. Now, all our questions here, not all of our questions, our last example and our first example, you needed sport utility vehicles or racing cars or What was our first question about?
Minivans and trucks.
How many vans and cars? Okay, those are whole number of events. So if we were to actually draw these, we'd be drawing those points, right? When we draw these graphs. Remember, I said you don't have to draw the points, but you should write whole numbers underneath, right? What about this amount of liters of gas? Can you get half a liter of gas or a quarter liter of gas? Yeah. So that one would be colored full, and those would be real numbers, okay? Elements of the real numbers. So you have to think about the case when you're graphing them. Come tomorrow, okay? Any questions right now?
The first and the last one,